Good morning, college math students. This is Mr. Unruh. This is actually the final week of the spring semester 2020 for the fourth quarter. Normally, this would be our last week of school. Next week would be scheduled for finals. But however, with everything that's going on, there are no finals this week. Unfortunately, there's no final, or fortunately for you, there's no finals. Unfortunately for you, there's no graduation, at least walking graduation at this point. One is scheduled for July. Hopefully, everything works out for to do that at that point. Anyway, this last week, 11.6 is annuities, funds, and investments. So, an annuity is basically we're going to look at how much money, if I'm putting a certain amount of money into a fund periodically, and how much will it be worth at a given interest rate over a period of time. We'll also look at then what's considered a sinking fund investment, which refers to simply if I know how much I need in the future, how much do I need to put in, say, monthly, quarterly, semi annually, or yearly in order to reach my goal at a future date. So that's annuities, funds, and investments. What you're going to be required to do is question number 2, question number 4, question 6, and 8 from the worksheet that's provided. 11.6 annuities, funds, and investments. I'm going to do on this recording, I will do number 1, number 3, 5, and 7. And also, there will be an assessment as every other week under the folder assignments and assessments under this week for May 11th. So what I will do is on Schoology, there will be question number 2 and question 4 as one assignment, and then there will be another one, which is question 6 and question 8, a second assignment, and then the assessment. Those are your final assignments and assessments for this week and for this spring semester. If you have any questions about this, I will be on Google Hangouts. You can also email me at any point. I'll respond to you and kind of help you out with the problem. So here we go. We'll start with question 1. Okay, so excuse me, here is the 11.6 annuities, funds, and investments worksheet. What I'm going to do is go through problem 1, 3, 5, and 7, and we'll just see how they work. So what you see is for problems 1 and 2, it says round to the nearest cent. Okay, and we give you the formula. A is equal to the principal times 1 plus the rate over n number of periods, n to the nt power minus 1 all over rn. What I'm going to do in here is want to just type in, let's see if I can do this. So let's go up here and I'm going to make this, I'm just going to type in here P is equal to principal, okay, or amount invested. All right. And then let's make that a little bit, let's go down here and say that R is equal to the rate, and is number of periods per year. Okay, so if you've got monthly, then it's 12. If it's semi-annual, it's 2. Quarterly is 4. Okay, and then below that, let's go with T is equal to time. Okay, so P is principal, amount invested, R is your rate, N is the number of periods per year, and T is time. Okay. And so what we're going to do is just basically plug those numbers into our formula and we will be all set. So let's clear that out and we should be all set. Let's go down here. Here's what I want to do with this. I'm going to go ahead and just copy. Okay, I'm going to copy that formula and then copy the formula, paste that in here, and just put some numbers in. Okay, so we're told that $800 invested semi-annually for 25 years at 7% compounded semi-annually. Okay, so um, for the P, let's put in 800. Okay, we got one plus. Now our rate, okay, our rate, let's see, our rate is 7%. Now don't just put 7 in there. That needs to be 0.07, 0.07. Okay, and we are told that it is compounded semi-annually. That's going to be twice a year. We put 2 in for n, and as far as our exponent goes, we need to get up here to the exponent, and n is 2, and that's going to be times, and we're told for 25 years. And in the denominator, again, we want to put in there, let's go with the rate is 0.07, and for our denominator of the denominator's fraction, we want to put in 2 for a semi-annual. Okay, all you need to do is simply plug in those numbers into your calculator. If you are good with the calculator and you can put all of that in correctly, okay, into the calculator, hit enter, you'll get that. If you need to do just the numerator first, get a value, do the denominator second, and get a value, you can do that. Okay, and so when you plug all those numbers in for number one, the accumulated amount of $800 invested semi-annually for 25 years at 7% comes out to 104,798 and 33 cents. Okay, so that's our answer for number one. We're going to do this something very similar to number three. What I'm going to do when I come down here to number three, okay, let's make a little bit more room on my paper here. Uh, if you'll notice, we have another formula. This is the same formula that we used for number one. It's just instead of A is equal to, this one is solved for P. So how much, this simply says do we need to, how much do we need to put in periodically in order to have an accumulated amount at a later date. Okay, so I'm just going to put our formula right here. We're told that annual payments with 5% interest compounded annually for 20 years to accumulate 35,000. So our accumulated amount, okay, we're going to put in there 35, 1, 2, 3, okay, and our rate again is a decimal, okay, and as opposed to just plugging in 5, it becomes 0.05. And if we are compounded annually, okay, our n simply becomes 1 in this case. And let's go down here and do another 1. And our rate down here is 0.05. Make that nice and red so we can see it a little bit better. And our N is the number of periods. Again, in this compounded annually, there's only once per year, and it is times 20 years. So we're going to make that just like that. Okay. And for this one, okay, again, with your calculator, plug those numbers in, and you should get, okay, 1,058.490522. Okay, that's what I get for my answer now. Since we are dealing with money, okay, we're not worried about the decimals after the 0.49, but we do want to round up or round down. So in this case, we're going to just say that P is equal to 1,058.49. Okay, so $1,058.49 put into an account at 5% compounded annually. If that's done for 20 years, at the end of 20 years, you'll have $35,000. Okay, let's get down here to number 5. Number 5 says to save money to start a new business, Brandon invests $200 each quarter in an annuity with 5% interest compounded quarterly. Determine the accumulated amount in Brandon's annuity after 20 years. Okay, so here's what you need to decide here. Are you looking for a specific amount to invest now in order to reach an amount that is given to you in the problem at a later date? Or are you given an amount that you're investing now and you're trying to find out the amount that the invested amount will accumulate over a period of time? So in this case, we are told that we're $200 each quarter into an ordinary annuity. It's 5% compounded quarterly. Determine the accumulated amount. Okay, so A is the unknown. Okay, accumulated amount is unknown. Um, P, that's $200, and our R is equal to 0.05, and the N, okay, this is told quarterly, so N is equal to 4, and T is equal to, we're told, 20 years. Okay, so there's all of our numbers. All we need to do then, since we are told that the A is unknown, I'm going to go get we're going to use the formula where we're solving for A and plug these numbers in and we'll be all set. Okay, so what I've done here for number 5 is I've got the formula that we use to solve for A. So A is equal to 200 is the P, the principal amount that we're putting in quarterly. Our interest rate is 0.05 or 5%. It is compounding quarterly, so 4 is the N, 4 times 20, and the N times the T. 20 is the number of years. In the denominator, you've got 0.05 over 4. All of that, okay, again with your calculator, all of that is equal to $27,223.76. So $200 invested quarterly, that is compounded quarterly at 5% after 20 years would be worth $27,223.76. All right, so question 7, very similar to that. All you need to do is just plug in the correct interest rate. Make sure you get the decimal correct on that, the $500. Same formula for 18 years, and you should be all set. Just use your calculator. Make sure your keystrokes and everything on your calculator are correct. So let's get down to number 7. Steve Nash would like to run for Congress in 10 years, would like to have $500,000 to spend on campaign expenses. How much should he invest monthly in a sinking fund with 6% interest compounded monthly to accumulate 500,000 in 10 years? Okay, so what I need to do here is get again, are we looking for how much he will have is the unknown how much he will have in the future, or is the unknown the amount that he's putting in at this point? Well, the unknown is how much needs to invest currently. So that is going to be the formula where P is equal to A times everything else. So all I'm going to do is scroll back up on my page here. Let's get the correct formula. And I'm going to just plug that in down here. What I want to do first is, so in this case, all right, and let's put this in red. P is equal to, that's our unknown. Okay. A is the accumulated value. That's going to be equal to the 500,000. Okay. Our rate is 0.06. And our N will be equal to, if it is compounded monthly, 12 months in a year, and T is 10 years. Okay, so T is simply 10. Plug those numbers into this formula and let's see what we get. Okay, and so I have plugged the numbers into the formula. We got 500,000 for A, 0.06 is R, N is 12, T is 10. Plug all that in, let your calculator do the work. You should get 3,051.025097. And again, since we're dealing with money, we're round that either up or down to the nearest cent. Okay. And since we have 0.025, we're going to round that up to 0.03. So Steve Nash, in order to have $500,000 in 10 years, he would need to put $3,051.03 into a fund that's paying 6%. Do that monthly for the next 10 years, and it'll be worth 500,000. So the question number 8 is very similar to um, question number 7. Just the numbers are different. So again, just there's two formulas. The one works off of the other one. You just need to know which formula to use. Are you solving for a future amount or are you solving for the present amount? P is solving for the present amount that you're investing periodically. The A is the accumulated amount you're investing, trying to find out how much you'll have in the future. Plug your numbers into your formula. Make sure you do everything correctly on the calculator, and you should get the correct answer. You should be all set. On the folder for this week, there is also another video which goes through the PowerPoint from the textbook, which explains this as well. And the answer key is on there, and then look to Schoology for the assignment. So hope all is going well. Again, if you need help, send me an email or go on to Google Hangouts. And that is it for today.